Welcome to qnawire.
Question.
Explains how to convert the Fischer projection of D-glyceraldehyde into a correct 3D representation using wedge and dash bonds. Step 1. Understanding the Fischer projection of an aldose. The Fischer projection is a two-dimensional representation used to depict the stereochemistry of molecules, especially carbohydrates. In the Fischer projection of an aldose monosaccharide, the aldehyde group, HO, is placed at the top. The primary alcohol group, CH2OH, is placed at the bottom. For D-glyceraldehyde, the hydroxyl group, -OH, is on the right side of the chiral center by Fischer convention. Converting to a 3D representation using wedge and dash bonds. To convert the Fischer projection into a 3D structure, 1. Horizontal bonds represent atom-slab bonds coming out of the plane of the paper toward the observer. Hence, in the 3D structure, they are drawn as wedged bonds. 2. Vertical bonds represent atoms' bonds going behind the plane of the paper. These are drawn as dashed bonds in the 3D structure. This approach preserves the stereochemistry at the chiral carbon. Explanation summary. Using the above method, we can correctly convert the Fischer projection using wedge and dash bonds without changing the configuration at the chiral carbon. This ensures the correct three-dimensional spatial arrangement of the substituents. Correct 3D structure of D-glyceraldehyde, the CHO group and CH2OH group, are shown as dashed bonds going into the plane. The OH and H on the chiral center are shown as wedged bonds coming out of the plane. This 3D depiction accurately represents the D-stereochemistry of glyceraldehyde. Conclusion. This method provides a systematic and reliable way to transition from a Fischer projection to a wedge and dash stereochemical representation, ensuring the configuration of the chiral center remains intact. The final drawing accurately portrays D-glyceraldehyde in 3 dimensions.